In topic 5, we will be looking at properties of systems of linear equations. So the properties of these systems that we will be looking at is the number of solutions that they could potentially have. Now, in order to find this, we are going to have to look at both of the equations in slope-intercept form, because the slope of the equation is the main thing that tells us how many solutions it will have. So for one, two equations of lines could have no solution if they are parallel to each other. And in order for them to be parallel to each other, they need to have the same slope. So an example of that would be if y is equal to 2x plus 1 and if y is equal to 2x minus 4. So here they have the same slope, as you can see there, their m value is the same, but they have different y-intercepts. So they're going to be running parallel to each other and they will never ever meet. So these two lines will have no solution. Now, one solution would be two lines that have different slopes. It doesn't matter what kind of different slope, as long as they're different, they will meet eventually once. So an example of this could be y is equal to 2x plus 1 and y is equal to 3x plus 1. So here they have different slopes, but they have the same y-intercept. Now the y-intercept doesn't matter for this. They could also have different y-intercept. So I just put here that these two equations could just be completely different equations. So both the slope and the y-intercept could be different. For this example, I just put the y-intercepts are the same, but that doesn't matter. And then for them to have infinite amount of solutions, and then two lines could also have an infinite amount of solutions, and that happens when they are the exact same equation. So if you were to put them in slope-intercept form and get the exact same slope and y-intercept, you would know that these two equations are identical. So for example, if we had y is equal to 2x plus 1 and y is equal to 2x plus 1. So the two equations have to be identical, and then that means they're the exact same line, and they will be touching in every single spot possible. So therefore, there will be infinite amounts of solutions. So for example 1 here, it says determine the number of solutions of each linear system. So we need to convert both of these into slope-intercept form so we can see that slope and we can see if the equations are the same or not. So let's just start off here with number 1, or I'm just going to label that first equation as number 1. X plus y is equal to negative 2, and let's convert this into slope-intercept form, which is really easy. It would become negative x minus 2 is equal to y. So I just moved that x term onto the other side of the equal sign, so we got y all by itself. So here's one of the equations. And then for number 2, we're going to move all the x terms to the other side of the equation. So we have 2y is equal to 2x, so that negative 2x became positive, and then plus 4. And then we're going to divide every term by negative 2 to get that y all by itself. So we're going to have y is equal to, now 2 over negative 2 simplifies to just be negative x, because that would be negative 1 over 1, which is just negative 1. And then 4 divided by negative 2 is negative 2. So if we compare these two equations, they are the exact same thing. So because of that, they are going to have infinite solutions. So exact same equation, your equations, therefore infinite solutions. So now let's try the second one. Again, I'm just going to label them equation 1 and 2 to help keep us a little bit organized. So for equation 1, let's convert that into slope-intercept form. So the first step is always to get that y by itself, so I'm going to move that 4x over. So we'll have 6y is equal to negative 4x minus 10, and then I'll divide everything by 6 to cancel that 6 out. So then we have y is equal to negative 4 over 6 would simplify to negative 2 over 3x, and then negative 10 over 6 would simplify to negative 5 over 4. So here is one of our equations. And then the negative 10 over 6 would simplify to negative 5 over 3. So here is one of our equations. And then let's do number 2. So I'm going to move that negative 2x over. So we have negative y is equal to 2x minus 1. So that 2x became positive. And then we're going to divide everything by negative 1 to cancel out that negative 1 in front of the y, or that invisible negative 1 in front of the y. So then we have y is equal to 2 divided by negative 1 would just be negative 2x, and then negative 1 divided by negative 1 would be plus 1. So this here is our equation in slope-intercept form. So if we're comparing these two, not only do they not have the same slope, but they also don't have the same y-intercept. So because of that, they have only one solution. So these are just two completely different lines going in different directions, and they will eventually meet once. So I'm just going to put here, totally different equations, therefore one solution. And then for the final one, we'll put them both in slope-intercept form, and I'm just going to cut ahead while I do that. Okay, so I got our two equations for C, and as you can see in both of them, they have the same slope but different y-intercepts. So here the slope is the same, but the y-intercepts are different. So I'm just going to put here same slope but different y-intercepts, and because of that, they are never going to meet. There is no solution. So these are two parallel lines that will never meet and never touch. So there's no solution for those. So if we scroll to the next example, it says, given the equation negative 2x plus y is equal to 4, write another linear equation that will form a linear system with exactly one solution. So this is just like a different take on these questions. So if we needed exactly one solution, it needs to have a different slope, and it can also have a different y-intercept. But the y-intercept isn't that important. As long as it has a different slope, that's going to give you two lines at different angles, and eventually they need to meet. So what we should do is rewrite this in slope-intercept form so that we can see what the actual slope is. So that would just be y is equal to 2x plus 4. So that was really easy for us. So the slope here is 2. So if we need exactly one solution, it needs to have a different slope. We can literally pick anything with a different slope. So instead of 2, I'm going to use, how about 1 over 3? That's a different slope. So 1 over 3x plus 5. So it's a totally different equation, totally different slope. So that would give us one solution. Now, if it has no solution, that means the two lines have to be parallel to each other. So in other words, they're going to have the same slope, but different y-intercepts. So if we were to write an equation like that, the same slope would be 2x, and then we need a different y-intercept than 4, so we can just pick, I don't know, plus 3. Sure, so these two lines have the same slope but different y-intercepts, so they are never ever going to meet. And then for it to have infinite solutions, it can be the exact same equation. So that would just be y is equal to 2x plus 4. That there would have an infinite amount of solutions to the original equation. Y is equal to 2x plus 4.